Welcome to Spring LIB.
Fortunately, I wasn't able to completely read the task because it's a little bit hard to read it. But as far as I understood, we have to find uncertainty in y of the linear of the function y equals to mx plus b. So let's do this. Y is a function of three variables. Therefore, uncertainty in y will look like the following. So it's the square root of partial derivative of y with respect to x when m and b fixed, multiply by error in x all squared plus partial derivative of y with respect to m when x and b are fixed, multiply by error in m all squared plus partial derivative of y with respect to b when x and m are fixed, multiply by the error in b all squared. Now let's calculate these partial derivatives. So the first partial derivative equals to m. The second partial derivative equals to x. And the last partial derivative equals to 1. So now we can complete this formula. So uncertainty in y equals to the square root of m multiplied by delta x all squared plus x multiplied by delta m all squared plus 1 multiplied by delta b all squared. But prior to the calculation, let's calculate y, because we need to decide how many decimal places we need. So y equals to mx plus b, which is 1.4 multiplied by 4.4 plus 0.8. So let's use a calculator to get this number. So it equals to 6.96, or if we take into account two decimals like in x and m, it equals to 7.0. So now let's calculate delta y and decide how many decimals we'll need. So it equals to m multiplied by delta x, which is 1.4 multiplied by 0.9 all squared plus the second component is x multiplied by delta m, which is 4.4 multiplied by 0.2 squared plus delta b squared, which is 0.5 squared. So let's calculate this number. It equals to 1.61, roughly 1.6. So I think we shouldn't round it to 2.0 because otherwise now current error is delta y over y. If delta y is 1.6 equals to 1.6 over 7.0, which is 22.0.229, which is like 22.9%. Or but if we presume that delta y is 2.0, so if we round it to 2, so it will become, the error will become 0.286, which is 28.6%. So we see that by rounding introduces too much of error. Therefore, we'll leave the uncertainty to 1.6. So this is answer to this question, 1.6. I hope I helped you. Thank you very much. Bye.